Good morning, everybody. I'm very pleased to be in such a wonderful team together with Professor Meng, Professor Ma, Professor Liang Gao, Professor Chen, Professor Zhu, Professor Wang, Professor Du. And these days, today and tomorrow, I try to share with you some information about terrestrial laser scanning and its application in cultural heritage or cultural environment or urban environment. But let me say a couple words about me. My name is Sorin Herban. I'm full professor of Politehnica University of Timișoara. This is located in Central Europe, and I will share with you some information about Politehnica. But let me give you some thoughts, some inputs about my background. I graduated faculty in 1996, and I graduated like civil, survey engineering. I finished my PhD studies in 2004 in civil engineering, and I had my habilitation thesis in 2016 in geodesy. So my background somehow it's linked between survey engineering, geodesy, and civil engineering. And this, sorry, this thing has an impact on my research because my research, as you will see, it's a mixture between civil engineering and geodesy. Uh, I'm part of Politehnica University of Timișoara, and I will share with you some information about Politehnica University. I hope you can see the slides. So, what is Politehnica University of Timișoara and what is civil engineering faculty? Politehnica University uh, of Timișoara, of course, is located in Timișoara. And Timișoara, it's a very European city because it's placed in a western part of Romania, very close to Hungarian border, very close to Serbian border. Actually, from Timișoara to Budapest, whose capital of Hungary, it's 3 hours driving. From Timișoara to Belgrade, whose Serbian capital is 3 hours driving, and from Timișoara to Vienna, to Wien, whose Austrian capital is 5 hours driving. So, as you can see, Timișoara, it's very close to some of the big cities of Europe. Some information about the achievements that were made in Timișoara during the time. Timișoara was the second European city and the first city from Romania with horse-drawn trams in 1867. In November 1884, Timișoara was the first town of Europe with streets illuminated by electrical lights. In 1746, in Timișoara were made the first engineering works for water supply and storage were executed. Actually, in a town very close to Timișoara, in Reșița, in July 1771, started the first furnace and forge being known and one of the oldest industrial facility in Romania and one of the oldest in all Europe. So in this context, it it was a big need to have a technical school, a university that prepare the specialists that can work in all the technical activities. So in 1920, Timișoara obtained the title of Civitas Academica or academic city. That and this thing attract to the capital of Banat many large foreign companies to provide Timișoara citizen with 10,000 of jobs. Till today, Polytechnica University of Timișoara has more than 130 graduates. I know that maybe from the universities and from cities from China is not allowed, is not too much, but for Romania, it's quite good number. And all these graduates have a great influence on the entire scientific, economic, and social cultural landscape in the Western Romania, and not just Western Romania. So we have more than 100 years of experience. We have 10 faculties, we have 25 departments, we have 25 research centers, we have more than 13,000 students. As you can see, we have 1,300 thousand graduates. We have a high rate of employment. More than 85 of our students are working in that field because, as you probably know, in the very dynamic market, labor market, the people are not working, the graduates are not working in their field where they graduate. But in Timișoara, 85% work in the field that graduate. We have 700 teaching staff, we have 600 administrative staff, and more than 200 agreements. In what's it's important to know that in 2011, Polytechnica University of Timișoara, or UPT, become the only institution in the western part classified as an institution of higher education and advanced scientific research by Romanian Ministry of Education. So we have, as our name is Polytechnica University of Timișoara, most of our faculties or programs are related with technical stuff, but we have faculty of architecture and city planning, who's more artist and technical. We have automation and computer engineering. We have chemistry faculty and environmental engineering. Of course, we have faculty of civil engineering. We have faculty of electronics and telecommunication, faculty of electrical and power engineering, faculty of engineering in Hunedoara. This is located at 180 kilometers of Timișoara. We have faculty of mechanical engineering. Actually, this was the first faculty that started in Polytechnica. We have faculty of management in production and transportation. We have faculty of communication sciences. We have 57 study programs. We have 64 master levels. We have 15 PhD domains, and I hope this fall we'll have another 2. We have over 150 PhD coordinators, and we have over 90 PhD studies every year. So where we have the agreements, we have all over the world. And in the latest year, we have developed a very strong relationship with China Academy of Science, University of Macau now recently, and also with Turkey, with the University of Antalya, and you can see it's all over the Europe, and you are very welcome to apply for coming for 1 semester or for your studies in Polytechnica University of Timișoara. Also, what we have in Polytechnica, it's a kind of program that is named double diploma. And as you can see, we have a large number of universities all over the Europe. But for civil engineering and for geodesy, We have double diploma with Constance from Germany, with Technical University from Munich, from Germany, and we'll open to develop new double diploma programs. We have partners from industry, very strong partners from industry that are in our advisory board. Most of them are in our advisory board. Polytechnica has an advisory board that is formed by people from industry. CEO of these companies are in our advisory board, like Continental, IBM, ABB, banks, Renault, and so on. I will not name all the Coca-Cola, Orange, and so on. This is our campus with our faculties, and the dormitories is in another part. And as you can see, we have a sport field, and around this sport field are all our faculties: mechanical, electrical, chemistry, electronics, computer science, civil engineering, and all these technical faculties are located in this area. Architecture, we have a very nice library. One sec. These are our facilities. I will not stay too long or our facilities, but as you can see, we have a very nice library. It was open in 2015. We have some sports centers where our students can do some sports. And what we did in Polytechnica, like a university, we try to access some European funds or some Romanian funds to attract or to develop new curriculums, not necessarily technical curriculums, but most curriculums that link to entrepreneurial thinking and labor market. So we have two programs in the latest here, and we have more than 600 students that apply to be entrepreneur under their graduation. So I wanted to present you some information about Polytechnica because one of the invitation for professor for my colleague to come at Polytechnica and have some classes, and also for all the students who are interested about Polytechnica, about an exchange program. We have a international office who's very open to collaboration. So let me know later if you have some intention about it, about that. I will now start more technical. One second. I hope you can see it. So my task was here to give you some information about introduction, concepts, and importance of remote sensing technique for cultural heritage objects. And just if someone work with laser scan or TLS, can raise the hand to see. I mean, you have emojis, and I just want to know if there are people in the room who worked before with laser scanning. I will stop share just to see. No one. Okay, maybe some of you who are looking at our broadcast worked before with TLS, but okay, just to know how to organize my class. So first of all, I will give you some information about the introduction in terrestrial laser scan technology. Light detecting and ranging, or LiDAR, Also, laser scanning, it's a system that use electromagnetic waves or part of it to make measurements or data collection from a station point or a mobile mapping vehicle or an aircraft to the objects that are locating on the terrain. Laser scan describe a method where a surface, a volume, a corpse, or an object is scanned using the laser with the purpose of capturing the reality. The Razier laser scan, or TLS, it's a quite new technology and was developed since the early 2000s for survey or topographical application for measuring precise distances and angles. TLS works using two kinds of technology, time of flight or phase shift. But both of them are creating 3D X, Y, Z location within millimeter potential to hundreds of meters. The advantage of laser scan is the fact that this technology or techniques can measure or record a huge number of points with high accuracy in the relatively short period of time. Current laser scanning technology can be divided in two categories: dynamic laser scan and static laser scan. The static laser scan is the case when the station or scanner is placed in the fixed position during the data acquisition. The advantage of using these methods are very high precision in a relatively high high density of points. The dynamic laser scan is the case when the scanner is placed on the mobile platform like car, train, plane, drone, etc. This system requires an additional position data such like inertial or GPS, which can make the system more complex, in some cases more expensive. The application of the laser scanning in dynamic way can be mobile mapping, roads, railroads, forestry. There are very important applications in forestry, space and security, and etc. For the static laser scan, we have three categories, like close range, who's specific to 0.5 meter to 2 meter, and the application in this class is on mechanical engineering, reverse engineering, medicine, structural monitoring, police investigation. Medium range, who's capturing the data from couple meters to couple hundreds of meters. And the application on medium range are civil engineering, landslides, management facilities, cultural heritage, and environmental studies. And also, we have long range from couple hundred of meters to couple kilometers. And the application in the long range are related with city monitoring, mining, and excavation, as-built surveying. And this as-built surveying can be also linked with building information modeling. And maybe some of you have some knowledge about building information modeling, environmental studies, and also glacier studies. The principle of laser scanning, sorry, the principle of laser scanning, it's very linked to the electromagnetic spectrum. I know that maybe in this part of the class or the course, the information are a little bit theoretical, but for sure, if you understand this theoretical information, it'll be more easier for you, or will be uh, you will be more yeah, it will be more easier when you will do the application with the laser scan. So that's why I will ask for you to have patience, because it will not last too long. But I wanted to give you some information also about theoretical principle of the laser scanning. So the physics define electromagnetic radiation of the waves of electromagnetic field propagating to the space, carrying electromagnetic radiant energy that includes all kind of waves, starting with radio waves, microwaves, infrawaves, visible rays, ultraviolet, X-rays, gamma rays, and so on. All of these are part of the electromagnetic spectrum. Electromagnetic spectrum is the range or frequencies of electromagnetic radiation and their representative wavelengths of photon energies. The electromagnetic spectrum can be more familiar that you might through the microwave you use the, to heat your food, the cell phone you use are part of the electromagnetic spectrum. The reason that we are seeing objects is because they emit or reflect or transmit part of visible part of the spectrum that we call the light. NASA created, and I know that some of you saw this diagram, but it's a really nice diagram, created a diagram that synthesize all these waves and their application actually. The electromagnetic spectrum can be expressed in terms of its energy, wavelengths, and frequencies. So the electromagnetic spectrum can be expressed in terms of its energy, wavelengths, and frequency. So as we can see in this diagram, high frequencies of electromagnetic waves have short wavelengths and high energy, and vice versa. Low frequencies have waves long and wavelengths with low energy. Because of the material reflects and absorb this energy differently, it means that each body will have a unique spectral signature that can be seen in this diagram. The spectral signature is differentiated by certain wavelengths and different intensities. However, the spectral signature of certain objects may be different over the time. So the determination of so-called temporal signature, it can be seen here. For example, water, yes, vegetation and dry soil were chosen. It is very important to specify that the values presented here are some average values. and any element can influence the graph. In any case, the clear water refracts less than cloud water. The radiation passing harder through the seconds and the most being return of the source. Sorry from some noise that it's made here. Uh, as I told you, I'm in vacation and I'm staying on the terrace, and some people are going with the cars in the front of the terrace. In any case, of soil and vegetation, the water plays an essential role so that if the water content is higher, the reflective will be lower. Also, the type of soil, the type of vegetation, and even the season matters because the spectral signature of the vegetation can differ a lot in winter compared to the summer. A first reason being appearance of leaves and flower, but also the different content of water. In addition, to those mentioned, the type and species of vegetation influence the reflectance, each species having a unique spectral signature, even if it's similar. Understanding all these objects was create a device that emit lights through a process of optical amplification based on the stimulated emission of electromagnetic radiation, or in other words, a device that is able to generate a wave of light using a very narrow band of the spectrum. This we call laser. A typical laser emits a narrow, low divergence beam with a well-defined wavelength corresponding to a particular color of the laser it's operating in visible spectrum. So, what is laser? Light amplification by simulated emission of radiation. Laser was created to generate a wave of light using only a very narrow band of the spectrum. As I told you before, a typical laser emits light in a narrow, low diverging beam with a very well-defined wavelength. Worldwide, laser, it's known and it was demonstrated in May 1960 by Theodore Maiman and Hughes Research Laboratories. Nowadays, lasers are used in a wide variety of applications, including scientific, military, medical, and commercial fields. All of these were developed since the invention of the laser in 1960. Actually, it was 1958 or 1960, I forgot. Because of recent development in ITC and sensor technology, light has been used in a number of ways to measuring objects. This data containing techniques integrated in scanners can be divided into categories. active scanner and passive scanners. Passive scanners, I will start with this one, do not emit any kind of radiation, but instead really on detecting reflected ambient radiation. The most scanner of this type detect visible light because it is a really available ambient radiation. Other type of radiation, such infrared, could also be used. Passive methods can be very cheap because in the most cases, they do not need particular hardware or other than a digital camera. The problem with this technique is that they really on finding the correspondence between 2D images which do not always have a unique solution and their properties. For example, repetitive patterns can fool the measurement method. So the accuracy of this kind of sensor depends mostly on the resolution of imaging system and the density of the identifiable features in the images. Active sensors emit electromagnetic radiation to collect data from objects placed on the terrain. Active sensors emit a kind of control radiation to detect reflection in order to prove an object in the environment. Possible types of radiation used include light, ultrasounds, or X-rays. Since these active measurements techniques require a laser transmitter and a receiver that are at least mechanically more complex than passive sensors. The most common sensor integrated in laser scanners equipment are using time-based principles that are active scanners that measure a time frame between two events. The advantage of using pulses for laser ranging its high concentration of transmitted laser power. This power makes it possible to achieve the requirement we call signal to noise ratio needed to high accuracy measurements at long ranges up to from millimeters or centimeters or meter up to hundreds of meters. And nowadays there are scanners who achieve also couple kilometers. The disadvantage is the problem of detecting the exact arrival time or backscattered laser pulse due to the changeable nature of the optical pressure and atmospheric attenuation. Active sensors emit controlled radiation. Laser scanners are part of this category, being used to forecast data in the form of dots, as you can see here, but also images on objects. The laser scanners can be like a total station that pick up points using the laser function. The advantage of the scanners is the automation in terms of taking the points located in both vertical and horizontal field of view. During a scan, from each scan point, the distances between it and the scanner will be recorded, as well horizontal and vertical angle corresponding to the direction of the point. There are a lot of companies that are producing or they are making the equipments in this category. I just want to share with you a couple of it, and I will share the equipment that I work with. And first of it is the ZF or Zororer and Fröhlich Imager 5010C. This one sets new standard from 3D laser scanning. Actually, the principle of laser scanning was patented by the Dr. Fröhlich in the 2005, and he sold to a big company the patent, and after a while he make a partnership, and the company Zororer Fröhlich, it's one of the companies that are building the very precise and very standardized laser scanner. Another company which is well known, it's Leica, and Leica RTC 360. It's one of the most advanced scanner available today. It can capture the points with millimeters precision, and it can do scan very, very fast, in actually in 1 minute or something like this. Focus Faro, it's another one. And this scanner, it's a high-speed 3D scanner with extra long range, scanning the objects up to 350 meters away, which is quite far. The FX scanner, it's an advanced 3D scanner designed for use in where fast acquisition of clean, accurate data is paramount. It can capture almost 200 points per second. To be able to measure multiple points from the scanner position and view to the laser beam, the laser beam needs to be diverged or deflected from the position in another position. Instead of moving the laser itself, a deflection unit was created. The most deflection units are using mirrors because they are much higher. Can those be rotated and much faster with greater accuracy? A number of methods exist to deflect the laser beam towards a specific direction without having to moving the scanner itself. In general, there are 3 methods responsible for this purpose. One of the options is to use an oscillating mirror or two mirrors that allows this beam to be deflected in two directions. That allows the laser to move along a line. To make this faster and more efficient, researchers have come with a reflective optical rotation prism. Recently, but a complex method has been defined, use control fibers, yes, as you can see here, that make system more flexible. This system deflects the laser beam into a circle and optical fiber through the mirror rotation. Of course, like every instrument, like every topographical instrument that measure distances, that measure angles, even the laser scanners have their errors. So I will share with you some of these errors. Some errors are instrumental errors in terrestrial laser scan. Instrumental errors, as you may know, they are systematic and random. They are due to the scanner design. Random errors mainly are affect the range measurements position and the angular location of the instrument caused by physical phenomenon measured by the instrument. And let's suppose that we have to scan or we have to measure an object and someone is just crossing between the station and the object. So it will appear the random errors. Systematical errors may be generated by non-linearity of the time measure units or by the temperature drift in the time of measurement process. Several categories of these errors I would like to share with you. And first of all, is laser beam propagation. Beam divergence is the laser beam widening in a distance traveled. Beam divergence has a strong influence on cloud resolution, as well the position horizontally of a measurement point. Practically, the beam divergence has an effect to an angular location of the point measure, the apparent location of the observation. It's along center line that emit beam. However, this beam divergence can be corrected in the process or in the process of processing the point clouds. Another error that is very common is mixed age error. One of the most important consequences of the beam divergence is the mixed age error problems. When a beam hits an object, it can be split into, or the beam can hit two objects that are located at different altitudes or different distances between the laser scan position and the object. One part of the beam is reflected by the first object, and the other part, it's traveling future to hit another surface. The result of this can be uh, not precise information. So this error is specific when we are working with high precision, like less than millimeters. And also it can be corrected by the process of cloud processing. Angular un uncertainty. The most scanners make or use the rotation mirror to guide the laser signal in a certain direction. A small angle difference can cause considerable coordinate errors when especially the distance from the scanner and the object is quite high or it's increasing. The angular accuracy depends on any error of the position of the mirror and the accuracy of angular measurement device. Axes also can create errors in TLS. The process of scanning are defined by the following axes: vertical axis, collimation axis, horizontal axis. Due to manufacturing tolerance, these axes are not perfectly aligned and leading to collimation or vertical errors, as well as horizontal axis errors can be also presented in the process. Another category of errors are related to the object or reflected errors on the object. And since the scanner measures the reflection of the laser beam for a surface, we have a couple of physical laws of reflection, actually two, and optical properties of material. The surface reflection of monochromatic lights normally show reflected rays in many directions, as you can see here. And we have a reflection of Lambertian surface. In the nature, the very black or dark surfaces absorb most of the visible spectrum. The reflecting signal will be very weak in these cases. Hence, the point's accuracy will be corrupted by the noise. Surface with high reflectance, like bright surfaces, give more reliable and precise range measurements. But not in all cases. We have a case in my laboratory in Timișoara when we try to scan an object that was made from inox or aluminum. And in this case, because high reflection of the object, the point cloud was with a lot of noise. The noise is the name of the, sorry, can you hear me? Murad Khan, if you can turn off your mic. Murad Khan. Murad Khan. Okay, okay. So what I tell you before is that the bright, very bright surfaces can create a lot of noise. So what we did, we paint this object to a gray, but we have to have in mind that from some precise determination, even the pellicula of the paint can influence dimension of the 3D object. So tomorrow, I will explain more about this application and I will work with you. But since then, we still have to have some theoretical information. And I know that for some of you, it's not easy to end it somewhere to look up theoretical stuff, but I don't have too much theoretical, and I will stop theoretical things and we'll go to the practical things after the break. So be patient, and I will continue. Besides the reflectance effect, a number of materials have semi-transparent coating that allows the laser beam to refract and then reflect in the material itself. The effect leads to an additional constant to distant measurements, which has to be regarded or correct in the computation. Also, we have environmental condition. We have temperature, we have atmosphere, and all this environmental, we have humidity, and all these environmental conditions are influencing the parameters and the measurement process. The temperature has to be taken in consideration. The environmental temperature and also the temperature of the scanner. Also, what we have to take into consideration is the temperature on the surface of the object that has to be scanned. While scanning, it's a process that are collecting the electromagnetic radiation or part of this that it emit from equipment. We need to take in the consideration the temperature of the object that it is measured. While scanning a hot target, when are scanning a hot target in, let's say, industrial environment, the background radiation goes.
Mute something and mute.
I think I muted. So when we are scanning a hot target in an industrial environment, the background radiation caused by the hot surface reduce the signal to noise ratio and those precisions and the range of measurements. Atmosphere also can influence the measurements, and laser scanners will only functional properly when we use a certain atmosphere and temperature range. Even within this deviation, measurements may be observed, especially in the distance measurements. Laser light velocity, it strongly depends on the air density. Anyway, in the case when the total station or the scanner and the object that we are measuring, it's not so far, the atmosphere density, it's not affecting so much our measurements. Interferencing radiation. Since laser scan operate in the very narrow frequency band, the precision of the range measurements may be influenced by external radiation. Another aspect is distortion from motion. The most scanners have a rate of collecting point between thousands and millions point per second. The average point period for a scan seen can be taken between 5 or some minutes and 30 minutes. So all these meteorological errors due to the process can influence the precision and the model of the 3D object. And to understand better how we need to develop a process to create a 3D object, we have to have in mind all these aspects. Okay. I think how much time we still have? It's 1 hour. I will take a short break to drink a water, and then we will go further. Just let me drink some water, please. I'm back. I'm back. So, the application using terrestrial laser scan are very diverse and covers a wide area of technical environment domain. So I may say there is no standard procedure for surveying planning of terrestrial laser scan, because some procedures can be done when we are laser scan or when we are using a laser scan to collect data from forestry. Some procedures, another ones, can be done when we are doing data collection from cultural heritage objects. When we are using terrestrial laser scan technology to measure the landslides or structural civil engineering elements, we are using another procedure. But there are some things that we need to have in mind when we are preparing to do. Can you hear me? Yes. When we are preparing to do data collection, just to give me Okay. It was a question. Sorry, I didn't see it in the. Okay. What kind of factors of high density expect our molecules has significant impact on the laser velocity? Just dust and air molecules had significant impact because it's and I use the laser scan usually for cultural heritage objects and also for civil engineering structure. In these cases, distances between the laser scan and objects, it's relatively not so high. You will see, I share with you some point clouds, and I will ask you to work with these point clouds later. But when we did in our laboratory very precise measurements, I mean, we are testing structural civil engineering beams or walls and so on. So when we are doing the laser scan for this, especially if they are metal structure, we have to keep in mind the nano matters are important to be determined. So in these cases, of course, the atmosphere has to be clean. The air, it has to be clean. But I will tell you later about all this stuff. Let me close the chat because it covered the presentation, and maybe you can see. You cannot see very good my presentation. So we need to have in mind some information and or a process when we do a laser scan, starting from survey planning or study design, yes, field operation and data collection, data preparation for data registration, data processing, and in the end, we have to do, of course, quality assurance before to deliver the final project. Gathering as many information possible from the object is important because in some cases, we need to place the object in the national, let's say, coordinate system. In other cases, we don't need this information to be placed in a special coordinate system. We can choose a local one, and our focus is to have the object precise as much we can. In these cases, at FIG was presented of some of my colleagues a diagram that can be followed to create 3D objects. I'm not sure if you can see it very well. Also, all these presentation are available for you in data in the model data, so you can find all the information there. But in this diagram, we have the process of laser scanning and additional process when the topographical instruments like a total station can help or can bring value to the scan position. Why we need topographical station? Because some of the targets, and we will come to the targets very soon. Some of the targets can be defined or can be measured to a topographic station to have X, Y, Z coordinates. So the registration process, I can say that it's more complex when we have topographical station, but it's more controlled if we are using topographical station and the laser station and the laser scan together. Why we have to use a laser scan? Because this might be a question that you have. Why we need a laser scan? If you are asking me how much is the laser scan equipment, it's between, let's say, 2 or 30,000 euro till 200,000 euro. So these equipments are not affordable for anyone, for any company. So in any case, if we have a very complex surface with organic forms, I think the laser scan, it's the only technology there that can capture the objects with the forms and in the precision that we are required. Also, because we need 3D results, because surface measurements are required, instead measurements at point to point, like total station. Of course, today we have also the digital photogrammetry available, but sometimes this, in the most of the cases, this technology cannot bring the same precision like the laser scan. Data records can be used by a different multidisciplinary team for different purposes. Also, we have archiving the information without prior knowledge for later use, like cultural heritage documentation. Yeah. Also, we have points that we cannot reach with another technology, or we have access restrictions. Also, when we are using the laser scan, especially when we are using for the precise data collection, we need to have in mind that the object has to be perpendicular to our total station or station position. If the object is not perpendicular, we need to have in mind that the beam print, it's different to different angles. In the most cases, a signal scan also is not enough to produce a complete digital model. And if we have this object, we need multiple positions to cover all the parts of the object to create the 3D object. All these scenes must be brought into a common reference system. This process is called alignment or registration, which will then merge to create a complete digital model. If we need to categorizing the registration techniques into a direct and to indirect registration, we need to have in mind the following aspects. The direct registration, setting the TLS equipment into base node point, like a traverse when we are using the total station. This direct registration techniques require a known network, require leveling in ordering to the scanner, and require a georeferencing system or additional instrument like total station, GPS, and so on. In the most of the cases, we realize then the direct registration technique can be too difficult. So the latest ways or fact that we are using the laser scan, it's to registration indirect. And this can be target to target registration or cloud to cloud registration. On target to target, we need to have targets on the surrounding objects, and we have to scan these targets. On cloud to cloud, it's more easier, but we need to make common scenes of the object, minimum 30%. Also, when we are using the indirect registration techniques, we can place the object into coordinate system. But in this case, we need that the targets has to be determined in the national system or the local system, and then we need the total station and GPS. Going further, and I would like to speak with you some things about 3D point cloud processing. Point cloud processing means a process of transferring the data registered or data determined point cloud into a final deliverable. These deliverables come in a wide variety of forms. Clean point cloud data that can be fully 3D texture models from animation or so on. Other scanners, companies show impressive videos of putting clouds turning into fully texture model. However, in reality, this process is still very time consuming. And I would like to say that if the data process can take like 5 hours, processing time, it's 3 or times more than data collection. Anyway, The results of the scan acquisition is a huge number of points in the space having x, y, z coordinates, usually for a reflecting laser value. Okay, I think now we will have some break, even it's a little bit early, but Liang, Liang, are you here?
Yes, I.
Okay. Can we take the break now and we will back in the 15 to 20 minutes?
Of course.
Okay, okay. Okay, then we'll take the break now and we will come in the 10 minutes. Yes, in 10 minutes from now, we will come and I will tell you more specific about laser scan and the process of registration point. Thank you very much. If we have questions, please leave me the questions in the chat and I will try to answer to all your questions. Thank you very much. Hello, I'm back. Hope you too. Okay. I have three questions here. So the point cloud, what's the point cloud? The point cloud, it's, let me show you. It's better if I show you. Is the process of creating 3D object by points that are measured by a laser scan or the laser techniques. This is a point cloud. As this is an all buildings in Timișoara, and it's measured by laser scan technique. This is the picture of the building, and that the other one was a point cloud of the 3D object of these old buildings. But I will answer to your questions detail in the following hour. Anyway, another question was regarded by the postdoc position. now we are in vacation, but yes, we have, and you have all my contacts in the end, and you can write me an email, and I can send you your questions and your demands to our international bureau, and they will guide you in the process of postdoc or PhD position. Okay, if there are any questions in the chat. No, okay. So we are back. So now I will be more specific, and I will present you the technology that we are using in our laboratory in Polytechnica University of Timișoara. We bought an equipment, a very good one. This equipment we have it in our laboratory. It's ZF 5010C, and it's an instrument, it's Theurer and Froelich 5010C, and it's an instrument that is capable to measure more than 1 million points per second. It's a high precision, and it's built with a tilt compensator. What we need tilt compensator? Because in some environments we have vibration. Anyway, in any case, it's good to be aware about this vibration, because this vibration can influence the precision of our measurements. But anyway, this instrument has a tilt compensator. It has a smart light and thermal cam slots, limo slots. Limo slots are used for thermal cam, smart light, and so on. It has a touch screen, it has a compensator, it has a Wi-Fi antenna, and this is the mirror camera. One sec. Camera and the mirror camera. We have what we need camera. Camera, we need a camera or digital camera because the laser scan, it's taking information, these dots. Let me come a little. So we will have all these dots about an object, but especially in cultural heritage and environmental research or domains, we need this color to these points to be colored. I mean, I use the word capturing the reality. If we are using just a laser beam, the laser beam, it captures the X, Y, Z coordinates of the object. But the laser beam, it isn't capable to collect the color. So to all these dots be colored, we need at least a camera and then a process that all these dots to be colored. So that's why we need mirror and camera. This instrument provides full HDR panoramic images to 80 megapixels from one scan, who's quite a lot. And also I share with you some point clouds, and I invite you to download these point clouds and download your program. You're gonna see in my third presentation some steps that you have to follow. And the first page in my presentation, it's about a cloud compare. So it's an open source program, and I invite you to download that program for the future application. And also, I'm sure that the Pi programs are working with the point clouds. So if you already have installed some PiSat programs that are dealing with point clouds, please be free to download the data and work with the data in Pi program. Also, what are the Zorn-Froelich 5010C characteristics? It has a laser scan class 1 with wavelength 1.5 microns, respectively with a measuring range between 200 meters and 0.3 meters. As I said before, the rotation speed capture 1,000,000 pixels per second. We can choose the resolution and quality of different labels, and this can be combined. It has a horizontal 360 and vertical 320. Why? Vertical is 320 because it has these edges in both sides and it cannot measure under the equipment, but the range is quite high. Of course, the information that is placed under the scanner, it can be measured by the second position, so it's not a problem. We have a quite big storage capacity and a full process of scanning, it's about 4 minutes. So this this is how it looks, the flash and the thermal camera. Yeah? Also, for registration, if you remember, I told you that we have direct and indirect. And from the indirect, we have two procedures, cloud to cloud. This scanner can do cloud to cloud, but in the cloud to cloud process, we don't have too much access to the parameters, and we are using the targets, these kind of targets, to have control about the process of registration. And in the indirect registration, we had the manual and the cloud to cloud. These targets are used for the manual registration. And you can see these targets have a number. This number is important because from two different scan stations, we have to choose the same target. I will show you later a little bit about this. But what you have to know is that we need these targets in the surrounding environment to register two scan positions that are linked together or that have to be linked together. So I will present for, I'm not sure if you can see, maybe it's good now. Okay. I will present you cultural heritage application in Timișoara and the process of registration or the process of bringing in the same system different scans. Let me see. Okay. If you have questions, please say to put me the question in the chat, and some time to time I will check the chat to see if I have the question. So I think all of you saw before this kind of buildings in the big cities, not necessarily in big cities. What I forgot to mention, and I would like to mention here, that Timișoara is the city in Romania with the manyest historical buildings. We have more than 13,000 historical buildings in Timișoara. I think just 10% of these historical buildings are rehabilitated. Most of them are not rehabilitated. So in the process of rehabilitating and painting these buildings, the architects, the civil engineering, the civil engineers need 3D models. To have these 3D models, we need laser scan technique. And let me show you what we did to have this building in the 3D model. So, first of all, we place in different position the laser scan, and we start to capture the reality. As you can see, there are some trams. Sorry for the noise. I talk about the noise, and I wanted to talk about the noise. There are some trams here. So if trams will cross in the process of collecting that data, we repeat the process of collecting data because we have some noise. I told you before about the noise, what the noise is. The noise is that kind of points that are not presenting the building itself, that are presenting another object, like this lady. This lady can be a noise. This car also can be a noise. If a tram it's crossing in the front of our equipment, of course, the information coming from the laser scan that hit the trams, also it's a noise. But sometimes we cannot delete all the noise for a single position. So we didn't have just a position. We placed the scanner here, we placed the scanner here, and in 5 or 6 positions to try to avoid as much we could from the noise we had. Okay. After recollecting data, we transfer the data from the scanner into the laptop or into the software that we will start the registration and processing the data. These scanners, it's equipped also with a thermal camera. As you saw, it was a very sunny day, and the thermal camera, I think it was in the spring, the outside temperature was about 24 degrees, So it was a perfect day for data collection. So we used a thermal camera, but we didn't have so much information about the thermal process or thermal anomalies, let's say, let's name like that. But if you are scanning in the winter time or in the very hot days, we will capture for sure the thermal anomalies in the structure, like cracking in the structure. Even if you cannot see, if you see the different colors in the wall, we definitely can have the hypothesis that in that part it's a crack. But let's go further. After the data collection, we have to color of these points because the points are uncolored. So what Dr. Froelich invented is to make a connection between the points and the color, the image in the front of the points. So each point, it's taking the fourth property. Each point has, first of all, the XYZ properties. Then all the points have the color property. This is the fourth one. And all the points have the fifth one, who's the time property. Yes, if you are scanning in the winter, in the summer, it's important to, especially in the environmental research or environmental studies. So the first step, and these steps are in the most of the, let's say like this, most of the equipment have their own processing softwares. We are use Thorer and Froelich ZF software to organize all the data. Leica have their software to organize the data. Trimble have their software to organize the data. But after the data is organized, it's colored, all the users can use like an open source solution like point clouds to deal with this data. But first of all, we colored the data. So the data, all the points will be colored. Then, because we have a thermal data acquisition station, we generate thermal camera scan of the project. Okay. Okay, this is the thermal camera of the project with infrared, yes? After that, the next step after we color, after we are generating the thermal camera, it's registration process. Registration process, it means that we link all the targets to between the station. The targets that are used are the paper targets. Yes, this is a paper target glue to the surrounding environment. Yes, these targets has to be linked between two stations. Check. Okay, so the process of the registration can be semi-automat. Semi-automat, it means what we are using the targets defined in the process, yes? Or this process, it's related when the program automate the center of the target. And this, the name is one. As you can see here, this information have to be placed by the operator in this field. The not automate, if it's, you can see here, it's not right in the center. Why it's not right in the center? Because the image, it's look very well, but maybe we didn't choose a process where the dots are hitting the center of target. So sometimes we need to choose the registration manual, and we will place right in the center in the paper target. And we use this point like a target. And after we defined all the targets in every scene, we will merge the different scenes that are linked by the name of the target and the target itself. And finally, we will have like 1, 4, 5. We have Bălcescu 1, Bălcescu 2, Bălcescu. This is the scenes, and these are the targets. We will link the scenes between the scenes and the target. And finally, we have the report. I would like to mention, and I would like to pay attention about this report, because this report is very important, and it gives you some information, critical information about the 3D model. In this case, the average deviation was less than 2 millimeters. And the maximal deviation was 2.5 millimeters. If the degradation of the cultural heritage object, if it's in this stage, that precision, it's excellent. If we are talking about the metal structure, the steel structure, the things will be different, because in that cases, the precision has to be less than 1 millimeter. But in this case, this precision are perfect for us. So we are going to the registration process, and finally, all the scenes are bring in the same coordinate system. Let me share another. One second. No. One minute, please. Okay. Another applications. One second. Can you see my screen? Can you see my screen? effective 3D modeling for heritage sites using terrestrial laser scanning.
Yes,
And
we
do you
can see
have-
the screen.
Thank you, thank you, thank you. Thank you very much for your feedback. I will give you some application because tomorrow we will deal, I will help you more to work with by yourself. But just to give you some information about a couple application that we did together with the team of Politecnica. So why we need models in cultural heritage domain? Because it's one of the priority of European Commission and European Parliament regarding Information 2020, who refers to making our heritage and cultural creation available to a wider number of citizens. There are financial opportunities, there is a big need on the market, and why not? We have expertise, we have equipment, and more others. So if in the beginning, the cultural heritage representation were made like this, we start around 2010 with some determination of the cultural heritage objects of the all buildings in Timișoara, right in the center of Timișoara using total station. As you can see, we can measure a lot of points, but most of these points are in 2D and some of them are in 3D. So someone asked me, what is a point cloud? This is a point cloud, and this is not a color point cloud because it was made with an old laser scan equipment. Lately, from 2015, we bought this scanner, and also we have digital photogrammetry. We have Matrice, we have Phantom 4, and we start to do complex representation using our equipment and our programs. We have a lot of softwares, starting with Pix4D, Agisoft, Thorn Fröhlich, Jover, Soliscan, Cloud Compare, Global Map, all the points from all the programs and software from Autodesk, Archicad, 3D Recap, and from the fall, we will have a laboratory full equipped with PySat program. So I would like to thank you for this, the PySat managers and my friend Tao, who helped me to have a laboratory full with the PySat program. So we have an application to a church in our area, and the demand of our beneficiary was to have a model outside, inside, and also in the attic, under the roof, with all the beams. So we use digital data collection, digital photogrammetry data collection, and we combine this digital photogrammetry data collection with terrestrial laser scan data collection. We have 50 scan station. We have a lot of paper targets, but in the end, okay, we saw the errors for 50 scan data collection. We have very good. We have. Sorry, someone is. If you can turn off the mic, I don't know who has the mic off, on. Thank you very much. Thank you. We have very good precision, and in the end, we choose to color to show to the beneficiary the precision that we work with, we choose to color the point cloud with gray, and digital photogrammetry, they have the same color like the reality. And you can see there is a interferation between the point clouds. Yes, these are the point clouds made with digital photogrammetry, and you can see the gray, they are terrestrial laser scanning, and all these points reflect the same object. And of course, in the end, we extract all the data from outside and inside, and just let me open another file with you. Okay, okay. 1 minute, it's starting the the software start. 1 second, 1 second. Okay. Okay. Not working. I'm on my laptop and the program is not working. I will start again. Just give me a few seconds. Sometimes we need to have patience with the softwares, and I know that all of you who are working with software that are dealing with big files. Yeah. Okay. Now it works. So from that 3D model, we extract all the structural information. I hope you can see my Autodesk Civil 3D program on your screens. And a facade, no, this is a section. It's a section because you can see all the bins in the attic. Yes, everything. So to extract all this information, definitely we need a model inside and outside. A section, front section. The architects can now come and put the colors and everything on it. So this is what I wanted to show you. Okay, stop share. One more minute. Okay. Share. Another application are in the recreating, not just creating, but recreating the old fortress and recreating, first of all, like digital or virtual objects. And one of the application of this kind we made in 2010, where we have to recreate some object, some cultural object from ruin. Yeah. This is the process of creating object, and in the end, you can see the virtual object. Actually, we choose to keep the rock stone that it's shown that we are in 2010 and have in the background the digital model. Till here we have ruins, and up from here we have the virtual object. Okay, so you have all the information in the in the in the platform. You have my email, and if you have some questions, don't hesitate to write me. For the tomorrow, I would like to ask you to look on the presentation number 3. No, number 3. Just 1 second. Oh, yes, now number 3. And try to download the Cloud Compare software, and also try to download all the or some of the files that I share with you. You will see that I share with you couple times of files. One kind of file is 1 by 1. This is a full scene, and it's quite big. It's a quite big scene. I'm not sure if all your laptops or computers will work with. So I extract the 5 point or the 10 point. So what this means? It's if we have 5 points, I extract just the 5th one, and I deleted the other ones, and the 5th one, and so on. So this means that the file 5 by 5, it's not so big, and 10 by 10 also is the 10 one. Yes, the 10 point from 10. So please, for tomorrow, install, download, and run the Cloud Compare software. If you have PySoftware who is working with E57, it's perfect for me, and I will try to help you to merge all these point clouds, and we will work together to merge these point clouds. And then I will give you some task for the next days, to create a video, to create some sections, and so on. So if you have some question, please. If you don't have questions, I know that someone new are working, someone new, maybe some of you are in resting in the bed, but just to hey, if you can open the video to just say hi and make a picture will be very nice from the end of this. Okay, super. Thank you, thank you, thank you. There is someone. Thank you. Okay, super, super.
Thank you, sir.
Thank you very much. Thank you very much for your patience and hope that tomorrow we are working together. So, Liang, if you can take a print screen just to put a, okay. Okay, guys, it was a pleasure to have you here and hope to see you tomorrow. How to apply, explain topic, more details. I'm a master student. Yeah, okay. If you can send me an email, Murad Khan, you have all the information in the presentation. Okay, bye bye guys. Bye bye guys. Have a nice day and nice classes. Liang, can you stop the recording? Okay. Okay, Liang. So see you tomorrow. I hope tomorrow I will have the internet connection good like today, and we can work together in the point cloud processing. Bye bye.
No. ما في